Here we're asked to work with rates and average rate of change. So, to get started here, just as a heads up, when you're going through the book here and you get to some place that has some sort of bolded lettering like average rate of change here, I usually write it down. It does a pretty good job of kind of describing what it means, having a pretty good definition as you know. As it goes throughout average rate of change, this is a pretty good one. So it says it's defined as the change in the y value divided by the change in the x value. So in a way, what I'm going to write that as over here on the right is that the change in y would be like, if you think of the slope formula, similarly, you subtract the change in y over the change in x. So it's very similar to like the slope formula that you're working with here. So if another way to describe it would be maybe if you use the term slope, but be careful because slope and average rate of change are a little bit different. And we'll talk about what that means throughout the course. But to start, here's where we actually start our problem here. So Macario started in Vacaville and drove to Davis, a distance of 28 miles. So real quick over here in red, I'm going to give us a little diagram here. So I went from point A to point B. This is about 28 miles from Vacaville to Davis, and it took 30 minutes. Most of his journey was spent on the freeway. He stopped when he got to Davis. So the first part here for A, it says, what was Macario's average speed in miles per hour? So first of all, as a fraction, remember we're doing miles per hour, which means that it's miles here on the top of the fraction because per is like a division sign per hour. So in the end, we want our answer to be in miles per hour. Right now, what we're given is we have 28 miles in 30 minutes, which is how much of an hour? Well, it's 0.5 hours. So no one says it like, hey, 28 miles per 1/2 hour. It doesn't really work that way. So to actually just get rid of this fraction, we can divide the two. So we can take 28 and divide it by 0.5, which ends up getting us our rate or miles per hour here of 56 miles per hour. And most commonly, you're going to see miles per hour like when we're driving in a car. Second part, it says, sketch a possible speed versus time graph for the trip. Then compare your graph with the graphs of your teammates. What do you notice? So in this one here, to sketch the speed versus time. So real quick, when we're going through this, I'm going to scroll down here a little bit. When I'm sketching out this graph, speed versus time. So I'm going to go time as the x value. Time usually goes with the x-axis. Let's just assume that going forward. And we're saying speed. And speed, remember, we're talking miles per hour, whereas time, we were talking hours. So sketch a possible speed versus time graph for Macario's trip, and then compare. So in this one, speed versus time, what we can do here is we obviously start at 0, 0, because we start at 0 hours, and our speed is 0 because we're starting up the car. If we're spending most of the time on the freeway, basically one way we could kind of do this is saying like, oh, they're gaining speed until they get to the freeway. And then let's say they hit, 65 miles per hour. And then they go that speed all the time that they're on the freeway. And then once they get off the freeway, they go to their stop and they end up back at 0 miles per hour again. So in this case here, this could be a possible sketch. It doesn't have to look exactly like this. The two important things to think about here is that it really should start at 0, 0 because we're starting at 0 miles per hour. And it really should end. This is after half of an hour, or we could say 30 minutes here. So we should really end at 30 minutes because that's how long it took them to drive. So in this case here, this is a pretty, standard speed versus time graph. Now, did Macario drive at his average speed the entire trip? So remember, average speed here is 56 miles per hour, which in this case, he definitely did not because you have to get to the freeway. And then the freeway, they were going a specific speed and then they had to slow down and then go to a stop. So it wasn't like they were going 56 miles per hour the entire time. In this case here, they were going, let's say, starting at 0, and then maybe at the freeway they hit 65 miles per hour. The final question here is kind of the most important. Did he ever drive the average speed of 56? Well, think about what average means. And if we're starting at 0 and we're ending at 0, we can't like skip to anything, right? As you like drive, you slowly get up to speed. You can't skip from 0 to 56. So you have to be below 56 to start. And then eventually, remember to average out, we say like if we're averaging out, maybe the 56 marker is somewhere down here, because really like we're going past that and we're averaging back down to 56 miles per hour. So one thing to think about is that really we should be hitting 56 miles per hour at least twice. A different graph could show that it goes more than twice. Let's say that it went up like this, and then it kind of, stop and go traffic, and then we finally got to the end here. Well, in this case here, if we're saying that 56 miles per hour is here, it could still average out at 56, but, we go 56 multiple times throughout the trip. But the key part here is that since we're starting at 0, at some point we have to go faster than 56 miles per hour to average out. And if that's the case, then we have to get past 56 miles per hour and then come back through here at least 2 points.